Hi all of you. Welcome to another lecture of nanoelectronics. The two topics for discussion today is the resonant tunnel transistor and another type of transistor, it is the hot electron transistors. Myself Maria Joseph, Assistant Professor in EC Department of MBC CET Pyramid, leading the session. In the last class, we have learned about the resonant tunnel effect and resonant tunnel diodes. Here, we are going to learn about resonant tunneling transistor. The resonant tunneling bipolar transistor have a resonant tunneling structure at emitter base junction region or in the base. The monolithic integration of resonant tunnel diode structure into emitter branch of the bipolar transistor is called resonant tunneling bipolar transistor. They are also called as RTTs or RTBT. In this case, the regular PN junction between the two terminals base and emitter is replaced by the RTD structure. Now, the resonant tunneling transistor. This is the basic structure of a resonant tunneling transistor. This adds a gate electrode at the top of the resonant tunneling device over the quantum dot. You can see that in the figure. It is now a resonant tunneling transistor. There is no resonance. Applying a small voltage re-establishes the resonance. This is basically an image taken from Google, so it is not clear, but I'll read that for you. The resonant tunneling transistors. The three-terminal resonant tunneling transistors versus two-terminal RTDs, that is resonant tunnel diodes. Enhanced isolation between input and output in the case of transistors. Higher circuit gain. Greater fan-out capacity. Greater versatility in circuit functionality. Better suited for larger circuits than RTD. That is only in circuits. That is the enhanced isolation between input and output. These are the properties of a resonant tunneling transistor over a RTD. Higher circuit gain, greater fan-out capacity, greater versatility in circuit functionality. That is, it can take a lot of other functions. Better suited for large circuits than RTD only in circuits. This is the diagram representing the RTBT in a circuit. This is how you represent an RTBT in a circuit. And these are the IV characteristics of a RTT. Figure B represents the IV characteristics. It reveals amplified collector current with typical negative differential resistance behavior. This device has negative transconductance in emitter grounded transistor characteristics. Applications, basically they are used in digital amplifiers, in digital electronics, that is in digital amplifiers. Next topic is hot electron transistors. The average thermal energy of electron is given by kT at thermal equilibrium. Okay, we know what is K. It's Boltzmann constant and T is the temperature. So the average thermal energy of electron is given by kT at thermal equilibrium. When electrons are accelerated, effective temperature arises. The new average energy is given by 3 by 2 kTe, where TE is the effective temperature. We know that, right? So here you represent it as 3 by 2 kT suffix E, okay? Because that will be the effective temperature. These electrons are called hot electrons. Here in this equation, it will be better if you write this as E is equal to 3 by 2 K into T suffix E, because it represents the effective temperature. There is a change of temperature when the electrons are moving. We learned it. This is a basic structure of a hot electron transistor. You have to study this structure. It has got an N plus gas, then intrinsic L gas, then N gas is there, N type, then I L gas, N plus gas. Here you have the collector, Here base and emitter. Then you have the emitter barrier is given. Emitter is there, emitter barrier is here. Collector is here, collector barrier is here. So that is the figure depicting the structure of a hot electron transistor, and this is the band diagram. You have to learn this also. Fine. Heterojunctions between different gap semiconductors allow generation of hot electrons. Electrons acquire high kinetic energy given by energy discontinuity in the conduction band. A transistor based on hot electrons is called hot electron transistor. When a positive voltage is applied to the collector, the injection of hot electrons coming from the emitter takes place by tunneling through thin gas barrier, since base is positively biased with respect to emitter. That is, we can see the emitter flowing down when a positive bias is given at the collector. Now about the applications, they are basically used in ultra high frequency applications. Thank you for patient listening. Thank you so much.